So we're going to finish up circles today. This is the last new part of circles. We just reviewed going over the angles and the arcs they intersect. We talked about where the vertices were. That was the important part. With circles and segments inside the circles, we're talking about chords, radiuses, diameters, things that are going to be on the inside and on the outside. We're going to talk not necessarily about the angles they form, but the lengths of those segments. So it's a little bit different. The pictures might look similar, but we're not worried about the angles and the arcs. We're worried about the lengths of the actual segment. So a little bit different. So here's our first example. And what kind of segments do you see in the circle? Think about your vocabulary. Do I have secants, tangents, chords, diameters, radiuses? What are those two segments? They're tangents. Now, most of the time we said that tangents were lines, right? And they went forever in both directions. These are just going to be tangent segments. Doesn't happen often, but it's happening here, okay? But they are tangent. That's important. And tangents, if they come from the same point, are equal. So there's really no work involved, just knowing that fact. So because the tangents come from the same point, they're equal in length. In other words, 15 is going to equal y. There's really no work involved. Okay? That's it. They're congruent. Done with that unit. Done with that particular part. Okay? Just looking to see if I have it on the other side. I don't. Oh, yes, I do. If you look at the other side of your green sheet, do you see that same picture on kind of the top, on the top right? Do you see how on that picture they're both labeled 10? Okay? Same idea as what we just did here. You can write that tangent definition right there. We'll do it after lunch too, but you can start if you want. All right, any questions? Just pretty straightforward, just a rule. All right. We already did an arc, so let's try this one. This is a formula, okay? I want you to think about the picture that you see. Don't worry about the dotted and the colors right now. Just think about the names of the segments inside of the circle. What are those things called?
Oh, chords.
Chords, very good. When we talked about chords before, didn't we talk about how this angle, x, talked about this x and y and z, sorry. Didn't we just review that this angle was half of the sum of the two arcs? We just did that, didn't we? Same kind of picture, do you agree? But the problem is that we don't care here about the angles and the arcs. In this problem, what we care about is what is the length of the particulars, what is x, which is a length. So when two chords intersect inside of a circle, there's a relationship between their lengths. And I've kind of written it here. This side times this side. I've color-coded mine yellow and green. When you multiply them together, their product is the same as the product of the other two. That's it. So what would the formula be in this picture? Is it hard to see back there? What the thing? So it'd be 4 times 10. And let's use parentheses for the time so we don't get confused with the x. Is equal to, what would the other side of the equation look like? 2x times 5. This is example 2. Yeah. You don't have to put the letters. You can just put 4, 10, 5, and 2x. I'll simplify the picture for you if it helps. Again, the picture kind of looks like something we've done before, doesn't it? Except for we're not worried about the angles and the arcs. I'm worried about the lengths of the segments. A little bit different question. So you just multiply the two pieces together instead of equal to each other. Their products are the same. So let's simplify. What's 4 times 10? 40. Okay, so 40 is equal to 10x. Where'd the 10 come from? 2 times 5. Divide by 10. Good. And I get 4. This was an easy algebra. Can you solve for these two lengths as well? What's the length of MA? Look at the picture. Well, we have x now, so I'm asking you what the length of MA is. The length of MA is 8. Very good. Because it's 2 times whatever we found for x. Well, x was 4. So MA is 8. What's the length of the whole thing of MT? 13. How'd you get that?
I added 8 and 5.
That's right. That's all you have to do. Is nothing, yeah, exactly. Okay? You just add them together. That's not hard, right? So if we look at the green sheet on the other side, hopefully we see a picture that looks similar to what we see here. I believe it's on the bottom left. So when we put it all together, we'll put that formula on our sheet as well. Okay? You're just multiplying the two together. Thumbs up? Doing okay so far? All right. So don't practice. I want you to just, I'll write the equation. I just want you to, you don't have to write this example down, okay? Tell me what I would do to solve this for x. Raise your hand. Someone can tell me what the equation should be. Go ahead, Devin. 6 times what? Good. So 2x plus 1. And then what goes on the other side? And, okay, so 15x. Is it okay if I can just write them like this? Okay. I've got parentheses because I have a binomial. Remember a binomial from last year? What do I do? How do I solve this? What's the step? What's the word? I thought I heard it. Distribute, right? So I'm going to distribute the 6. I don't have fractions to get rid of, so I don't have to multiply to get rid of the fractions like we did last class. So I have 12x plus 6. Don't forget to distribute the 6 to both. And then we have 15x. Now what?
Subtract 12.
I think you should subtract the 12x, because if I subtract 15x, I have nothing left over there. So we don't want that. And then I divide by 3, and I get x is equal to 2. Right? I could find the lengths if I wanted to. If I asked you to find the length of AC, what would I do with that x? Well, I'd plug 2 in. Let's find the length of AC. The answer's not 5.
No, the answer's not 5. No, it's 11.
11.
How'd you get that, Q-say? So I know it's 6 plus whatever, and then I have to plug the 2 in, don't I? So it's 2 times 2 plus 1. Oops, 1. Get out of there. Ends to be 11. Good. Very good. All right, no problem. So we know what to do if we have this situation. The others, when we have segments, they're not going to be inside the circle. They're going to be outside the circle, okay? So our outside situations are going to look like this. So I'm going to have you write the formula down, but not here. I'm going to have you use a different one. Let's just look at it. When our two segments intersect outside the circle, we're going to think about the segments in terms of the whole segments and parts. So I've color-coded this one to be yellow and green. It's going to be the whole part, or the outside times is the outside part times the whole equals the outside part times the whole. So think about what I mean when I say the outside part. Do you see how AB is part of the segment that's on the outside? So it's outside times the whole, and over here I have AD also is an outside part, outside times the whole. Are we okay with that process, that thought? Okay, outside whole, outside whole. That's the only thing you really have to remember, other than the two that cross in the middle. So let's write the formula down, okay? So this is going to be the formula. So I guess we'll call this, won't be example 3, but you can write the formula down. It should look familiar to you because you have something similar to it on your green sheet that we'll fill in after lunch. The blue part here is the whole. Sometimes you have to add them together. Here's an example of how I had to do that. A plus B is the whole segment. So I have the outside, which is just A, times the whole. Outside times the whole, outside times the whole. You're still doing this. It's just the whole had to be a sum this time. Okay? All right, everyone got it written down? I want it written down. I can go back if I need to. Okay so far? I don't want you to write this one down. I just want you to notice something. This picture looks a little different than the one we just did. The one we just did were two secants. Would you agree? They go through the circle. When you look at this one, I have a secant and a tangent. Doesn't matter. The formula is still the same. It's still outside times the whole equals outside times the whole. It's just that if you notice up here, the outside and the whole are the same. Does that make sense? So A and A are both outside and whole. Doesn't matter. Just, I don't want you to memorize another formula. Okay? Outside times the whole equals outside times the whole. It's the same thing. How about this one? What do you think?
Outside the whole, outside
It's the same thing. So I don't care if you have tangents, tangents and secants, or just secants. It doesn't matter. You're still going to use the same formula. Okay? Perfect. Let's try some. These are example 3 and example 4. Let's see what we can get through before lunch. Let's start with example 3. Again, because they don't cross on the inside of the circle, they intersect outside of the circle. That's where I'm using my outside times the whole is equal to outside times the whole. So what equation am I going to use here? Let's start with the 12. Is 12 an outside or a whole?
a whole.
It's both. So it's going to be 12 times 12. Are we okay with that? Equals, now let's look at the other segment. What's the outside part of the other segment? 8 times, no, the whole. The whole thing is not just x. It's 8 plus x. You're just going to add them together. Are we okay with that? The whole thing is the sum. So 8 plus x. Outside times the whole, outside times the whole. So now it's just a matter of solving it. I have 144 is equal to. Got to distribute, right? Be careful. Very good. 64 plus 8x. I love it. And now it's a matter of just solving. How do I solve? Can't divide by 8 yet. I mean, I could, but let's subtract 64 first, and then we'll divide by 8, okay? What do you get over here? Good. So what's x? X is 10. Very good. The hardest part of these is not going to necessarily be the algebra, I hope. It's coming up with the equation. and being able to know it's outside times whole or if it's piece times piece. So let's look over here. Let's look at example 4. Let's get the equation set up. Outside times the whole and outside times the whole. What are we going to do here for my equation? Let's start with the, well, hang on, Derek had his hand up. Let's ask Derek. Go ahead, set us up for us.
Oh, this would be 5 and parentheses 5x plus 4.
I'm so glad that you didn't say 5 times x plus 4, because that would be wrong. Look at what's inside the parentheses here. Inside the parentheses, I had to add the 2 pieces, right? So if I'm thinking about it, it's outside times the whole. The whole piece is the green. You have to add them together, okay? Whereas the outside piece is just the 5. You okay with that? Outside times the whole. Let's use the other equation. We'll use the other segment. What would that one look like to you? Again, outside times the whole, Derek. Finish it off for us.
6 parentheses.
Yeah. And if you want to just write 16, that's okay. I like the way you said it. It reminds you have to add them together. Beautiful. Make sure you understand the equation first. How do we feel? Okay? So now it's a matter of simplifying. And so we got to get our algebra straight. Okay? Got a lot of algebra going on. Is it okay if I combine the 5 and the 4 right away? I'd rather than distribute the 5. I'm going to combine those first. Just combining like terms. So I did. Now we'll distribute. Beautiful. Yeah, exactly. 5x plus 45 is equal to, thank you, 96. Love it. Now what? Okay. I think we're going to get a decimal here. Does that bother you?
No. No.
10.2. Yes. No. Yes. 51 divided by 5. So don't let decimals freak you out. That doesn't mean you did it wrong. It just means that it happened. Okay, that's all right. All right. How do we feel? Okay? All right. So, get out of my way. All right, so after lunch, we'll come back. We'll go ahead and fill out the formula sheet on the green, and then I do have some practice problems for us to work on.